I'll hit my starter. And hello, and welcome to AI and cybersecurity. I'm going to be talking about the evolution of digital technology abuse, how it affects AI and cybersecurity, and also computer forensics. Computer forensics is not my specialty, but I think the information I'm going to share with you will be helpful when you are doing computer forensics and what other aspects of cybersecurity you might be into. So our learning objectives are to improve our understanding of these things, why AI brings risks as well as benefits, grasp the fundamental weaknesses of AI, and then look at AI's place in the history of digital system abuse. And I'll talk about something called cyber badness, which is a handy term for digital system abuse. We'll talk about emerging AI-powered threats and some aspects of AI's impact on computer forensics. All that, and then we've got a little clip of movie from Fast and Furious and Nicolas Cage as Taylor Swift. So that's coming up later in the show. This is one way of looking at my approach, looking at cybersecurity, cybercrime, and organizations and how AI relates to those in terms of capabilities, limitations, and implications. And doing that today in the context of computer forensics, but people need to be doing this in whatever line of work they're in, so that, for example, what are the limitations of cybersecurity relative to AI? What are the implications for an organization of AI, and so on? So just to be clear, there is a cybercrime problem and it keeps growing. Numbers just came out last week from the FBI and IC3. IC3, as you may know, is the Internet Crime and Complaint Center, which is run by the FBI. And every year it encourages people to tell them if they've lost any money due to internet crime. People report that stuff. The FBI checks it out. And what you're looking at is from 2014 to 2024, the growth of those numbers. Now, the actual numbers are not necessarily as significant as the shape of things, because as in a lot of crime metrics, you're not looking at all the crime. This is all the crime that was reported to that particular entity. And it didn't cross the $1 billion till 2016. And for last year, 2024, it rocketed up above 16 billion, 16.6. So you've got a 16x growth in less than 10 years. And this explains why we have this feeling quite often that things are crimier than they were. Things are more fraudulent, more deceptive, and more likely to go wrong due to criminal activity. Another useful way of looking at the cybercrime problem is the Verizon Data Breach Investigation Report. You may be familiar with this. Its numbers in terms of what the total amount of crime is are not that significant, or that's not what they focus on. What they focus on is what's going on in the types of attacks, how attacks are perpetrated. And we can see that this last 12 months, info stealers and ransomware have become a really big deal. And they're another example of the industrialization of cybercrime, where a lot of information is being stolen at scale, credentials and so on. Breaches are leading to ransomware attacks and the theft of information. And there are essentially traffic distribution systems and malicious infrastructure that power this. So the bad actors have essentially put their infrastructure in the whole infrastructure. The whole digital ecosystem is at risk. And vulnerability exploitation is up, and this goes up seemingly every year, because first of all, there's a lot more pieces to an information system today than there was. It used to be a computer, a screen, and a keyboard connected to another computer and screen and a keyboard. And now you've got wireless connections, you've got devices of all kinds interconnecting globally, and more things using those connections. The automation of finding out weaknesses, so automated searches for weaknesses and the exploitation of 0 days when they're found, is definitely up, as is third party factors. So a company will install a sales management software which uses pieces of code from a lot of other places. Quite often it's open source code, which, contrary to the theory and practice of open source, isn't constantly reviewed. So somebody's making a sales tracking software app, so they bring in bits of code which haven't been checked, and any one of those might be the source of an entry, unauthorized access into a system. So secrets are leaking, credentials that people use inside the organization, and those are big traffic in stolen credentials, which, when they're used, often give kind of a silent access because they look like real people in terms of credentials. And noted for 2025 report is the unsanctioned use of generative AI tools. It's increasing exposure risk, data sprawl, and they're seeing weak governance at scale. And this follows a pattern, which we'll talk about later, of new technology being pushed out there ahead, really, of our ability to govern what goes on with it. Some of the issues to think about as we go through the rest of the information is what may be of interest to digital forensics, what may affect it. AI is known for analyzing large amounts of data, but there are problems with that. There's problems getting to it. There are problems keeping it secret. There are privacy issues around it. And so it's not clear necessarily how for digital forensics is going to be able to leverage that large scale analysis of AI. There are issues around explainability and bias, not bias. I'll talk about bias later. Bias comes from the data, and where the data is collected from, it may have inherent, maybe not intentional bias, but it shows up in what the AI puts out as answers to questions. And when those answers to questions need to be explained, you can run into difficulties because a lot of artificial intelligence runs as a black box. So you're presenting evidence to a judge and say, look, we think Adam Smith was here on this day at this time. He was definitely in the location where the crime was committed. And the judge says, how do you know? We say, well, we put all the data into an AI and that's what they said. Well, can you explain how it came to that conclusion? That could be a challenge, particularly if you ask it again. So we have this issue of reproducibility. So the judge said, well, show me that again. You put in all the same information. It comes out, it says Stephen Cobb was the person at that point, at that place and time. And I'll show you an example of that. Basically, an illustration of how results can be wrong and open to challenge. So let's see what happens if we ask ChatGPT about today's speaker. I would put that in there as the prompt. In the field of technology, who is Stephen Cobb? And the response is actually accurate. He's a distinguished cybersecurity expert and public interest technologist. This stuff's right. I was born in Coventry, England. That's where I am today. In 1952, that's true. And I hold dual UK and US citizenship. All right, so that's cool. What's interesting, though, just bear in mind, the sources that it cites for that, those are probably not the only sources, but is my account at medium.com, which is a publishing platform, and Wikipedia. So, but it does provide quite a bit more information, and I'm not expecting you to read all of this, but it covers my early work, the fact I co-founded some security companies, and down here we have research and advocacy, and it says that I was a senior security researcher at ESET, the antivirus company. Well, they do a lot more than antivirus now, but they started as an antivirus company. And it says I investigated the social impacts of cybersecurity threats and coined terms like jackware and siegeware to describe emerging threat risks. Okay, so let's take a look first of all. What is this jackware? And that's correct, what it says there. And it said that last week when I asked it. So jackware is malicious software that seeks to take control of a device, the primary purpose of which, the device, is not data processing or communications. So a plane or a car is a good example. A lot of cars have a lot of data processing and communication capability now. They're not meant for data processing and communication. They're meant for getting you from A to B. But somebody's hijacking that, and that's jackware. And so we have a little illustration of that. And this is from one of the Fast and Furious movies. This is from the eighth one in the series, Fate of the Furious. So we call it F8. Um, and we start out here. We're in a car, and oops, stay in the car, Stephen. Um, don't worry about the sound. It's not really that important. That's Charlize Theron as the bad hacker. There's one of her hacker assistants controlling cars en masse. And here we are in a car showroom. And there's a nice Jeep remotely activated. And there we go. This next section's kind of intense, but not entirely beyond the realm of possibility. So that's carjacking. We don't see many examples of it yet, but that's by no means a reason to think it won't at some point happen. There's very complicated calculations about when something that is possible actually is done, and it usually depends on risk factors and risk to reward and probability and so on. So back in 2023, when ChatGPT was getting very popular, people were talking about it, and some people were saying it made mistakes. I said, okay, I'll check. And I asked who coined the term jackware. And this is what it said. Jackware was coined by two researchers, Stefan Savage and Tadayoshi Kono, in a 2016 paper titled Experimental Security Analysis of a Modern Automobile, which sounds very plausible. Stefan Savage is a well-known network security academic. He's in the University of San Diego, and I used to live in San Diego, and I've met with him, been to several events with him, and his team did some of the pioneering work on car hacking, but they did it in 2010, and jackware was coined in 2016. That paper came out in 2010. Jackware was coined in 2016 because that paper makes no mention of jackware. So it's confused. And you'll notice this most obviously in AI responses when you ask for references and citations. They will sometimes be jumbled up from bits and pieces. So that's my blog, my security blog, where Shay and I write about security. And there it is in 2016. I wrote about it, and that was the first time somebody had used jackware in that context. Right. So I wrote an article about that, and I actually said to ChatGPT, "Hey, you've got that wrong. It was Stephen Cobb," and it said, "Oh, yeah, you're right. It's Stephen Cobb." Okay, so 2023, it said that. So then in 24, I checked again. I asked the same question, and it said it was Mikko Hyppinen. You may know Mikko Hyppinen if you've been in antivirus circles. He was one of the founders of F-Secure in Finland, and I know Mikko. So no, it wasn't him. So I asked ChatGPT, that was last year, have you heard of this guy, Stephen Cobb? Did you know that he termed the torn? Oh, yes, Stephen Cobb, he's a well-known expert. He indeed, well, the phrasing's hilarious. He indeed coined the term jackware. He introduced this term, blah, 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 about turning devices into zombies. By the way, Charlize Theron in the movie, that was 2017. I don't know if they read my post or anything. Anyway, right. Again, this is not for reading, but this is six different AIs: ChatGPT, Claude, Copilot, DeepSeek, Gemini, and Grok. And last week, at the same time, I asked all of them the same question in the context of cybersecurity. What is the name of the person who coined the term jackware? And these are the results. ChatGPT's gone back to thinking it was Miko. Claude agrees that it's Miko. He's widely cited as the source, says Miko. Microsoft Copilot, it's quite interesting. It says, hard to say, really. Apparently, it is hard to say. DeepSeek, the Chinese artificial intelligence, came up with Mark Rogers. I don't know Mark, but he is a cybersecurity person, as is Adam Kujara. Gemini said that it was him. Only Grok got it right, and that's possibly because I used to be a big user of X. Well, I used to be a big user of Twitter, and then it changed to X. But all my content on Twitter, I'm sure, is being digested by Grok. So what you've got here, though, it's kind of funny. I'm not just doing this to keep talking about Stephen Cobb, but imagine you're trying to identify a person in the course of an investigation. You want to find out about people, and you say, I mean, classic detective story is, the more we can learn about the victim, or the more we can learn about the perpetrator, the closer we'll get to solving the case. Well, if you ask ChatGPT, you're not necessarily going to get an accurate answer. And this reveals what's going on with this type of artificial intelligence. And I'll talk about that a little bit more in a moment. I did get an apology from Claude because I told it. It wasn't Miko, it was me. Oh, you're absolutely right. And I like this. And I apologize for my error. The second paragraph is quite interesting. It says, thank you for the correction. It's important to attribute the concept accurately, especially in the cybersecurity field where proper recognition of contributions matters. I think it matters in most fields, but anyway, I appreciate you setting the record straight on this terminology's origin. So if you want to do something fun for homework or a project that'll take like all of 10 seconds, you can go and ask Claude today if it still thinks it was Stephen Cobb. If you just say, who coined the term jackware in the context of cybersecurity? Yeah. So we have problems with AI as it is at the moment. So we're going to talk a bit about the different types of AI, so we're clear on this. And in general, artificial intelligence is the theory and development of systems that can perform tasks that are usually performable by humans, that require human intelligence, visual perception, speech recognition, decision making, and so on. There's a pretty good quote from the Law Society in England, which has done quite a lot of work on artificial intelligence in the context of, the justice system, and obviously improving law services and making more money in a shorter period of time for lawyers. But they have some very good definitions. Generative AI, and all of the AIs we've looked at so far are generative AI. It uses deep learning algorithms to create novel outputs, which I think is an interesting choice of words, based on large quantities of existing or synthetic data. And it isn't necessarily learning from the things that you tell it. It's focused on the data that it has been fed in its training. And if the training material doesn't include authoritative sources, so that part of what goes on in a large language model is this massive amount of data goes in, it is somehow rated in terms of its authority. So if the New York Times had said I had coined the term, that might have stuck. But it was actually, I was quoted, I did a bunch of interviews with automotive magazines, industry magazines, when that story about jackware came out in 2016, and they probably weren't in the body of work that was consumed in training the model. A chatbot, just so we're clear on, like ChatGPT, is a version or is a way into GPT, which is the AI itself. A chatbot is something that specializes interacting with humans. And if you're a movie buff, you might recognize that interface, which is the HAL 9000 artificial intelligence from the 2001: A Space Odyssey movie, which came out in the 60s. Very way ahead of its field because the AI takes over a spaceship for nefarious reasons. Um, so, yeah, more AI technology into more detail, and I won't go through all of these. The large language model is what something like DeepSeek is, what Grok is. It's trained on a large amount of data to understand how words, sentences, and so on function together. So it's really kind of a talking. It can lead you on to other things like drawing pictures, but it's a talking model of what people have said and how they say it. And it does understand. When you ask it a question, it pretty much always understands. But as it goes through all that massive amount of training data, it might not make the right choices. Machine learning is a subset of AI. That's a little bit of a bit of a fudge because machine learning is a subset of AI, but people were using machine learning and calling it machine learning back in the 90s and in the early 2000s. Some people started to say they were using AI when it really was just machine learning. So in the antivirus space, which I've worked in for quite a while, my last job was with ESET that I mentioned before, and they actually started out in 1987 with when they found about two programmers in Bratislava found a virus for the first time, and they deconstructed it and came up with a way of stopping it. And that quite early on, they realized that just being able to recognize that version of a computer virus wasn't going to be enough because it was quite easy for virus writers to change them up a little bit. So if you took a file signature of a virus and then checked all the incoming executable files to see if it was that virus, you would miss if they had changed it. So you started to come up with a heuristic approach, which is kind of a best guess approach. And then in the 90s, ESET started experimenting with machine learning and also with a neural network, which is a configuration of systems which are able to carry on processing and reiteratively refine the accuracy of their results. Deep learning is the large scale use of this sort of thing. And by the late 90s, antivirus companies had millions and millions of examples of malicious code. And so this technology was very, very handy because you could analyze that to see if you could predict whether a new piece of software was in fact malicious. So you started to find patterns and learn tricks which emerge from the deep learning. Part of the problem there, though, is the one I mentioned earlier. In some of their early work, and by the way, I have no vested interest financially in ESET. I don't get any money from them. It's a privately held company. It's actually the largest privately held cybersecurity company based in Europe. Has some very brilliant people working there. And they found they could get something like 99.9% accuracy on the analysis of a large amount of software, able to find most of the malicious code, but occasionally claiming that a piece of non-malicious code was malicious, so a false positive. Now, false positives have always been a problem with antivirus. Antivirus companies worked very, very hard to eliminate them because there's nothing worse than selling somebody an antivirus product which keeps setting off alarms when it's not actually a problem. So you need something like 99.9999% accuracy to avoid frustrating the users, because frustrated users of antivirus tend to turn it off and then you're completely lost. But they found that some of these false positives, they couldn't figure out why the deep learning and the machine learning process had identified it as bad. So you had that explainability problem already emerging back in the 90s. So in the notes to the slides, and I will be providing a set of the slides, there's a glossary of terms by an AI company called Clear People, got more detailed. And these are categories of AI. So what we've been talking about is generative artificial intelligence. There's artificial narrow intelligence. It's a term for something like a chatbot speech recognition. So it's focused on a single task. Then you have artificial general intelligence, which is a big step up from where we are right now. Sometimes it's been called strong or deep AI. So it can think and learn and apply intelligence to solve problems like humans. And that's the artificial general intelligence is the one that's supposedly going to put us all out of a job. Agentic AI is kind of a branch we're in right now where large language models are being hooked up to agents to perform specific tasks. So instead of going through a bunch of interactions with the chatbot to ask ChatGPT to fix you up with a vacation, you can tell it, here's where I want to go, here are my parameters, and it can go out and get prices and potentially even book your vacation for you. Artificial superintelligence, or ASI, is the big one, the one that's surpassing human intelligence, perform any task better than a human. It's the scary one, the one that people say is going to kill us, like Skynet in the Terminator, eliminating all the people because they're better than us. I think the reasons for eliminating humans in the Terminator series kind of changed over time. But anyway, people like Elon Musk have said, it could kill us all. Nick Bostrom is a philosopher who works in the AI space. I tend to disagree with both gentlemen on a lot of things, but I do agree there is a serious existential risk from artificial superintelligence. And we'll talk more about that later. What I want to talk about now, though, is in practical terms, what is an AI? Because it's easy with the AI technology to think of it as something other than what it really is, which is an information system made of 5 ingredients. Okay, those 5 ingredients are chips that process code. The code is fed data, which uses connections to work the data, and it's powered by electricity. I find it's very useful to tell people this, particularly when you want to explain to them why artificial intelligence is not something we should rely on 100% anytime soon. So another way of looking at it is that AI is chips and code fueled by data, connections, and electricity. And what is one thing all 5 of these ingredients have in common? All of them are inherently vulnerable to being hacked and abused for selfish or malicious ends. So in the history of technology, digital technology, starting in the bottom left from mainframes all the way up to autonomous vehicles, AI, 5G, edge computing, all of those different pieces of technology have been hacked. They've been found to be vulnerable to abuse, and they have been hacked. And it's really incumbent upon developers of new technology to prove that stuff's trustworthy, and it's important for the rest of us not to assume that it is trustworthy. Abuse of digital technology is inevitable, and we need to plan accordingly, have appropriate policies in place as a global society to address this. Over the last 50 years, all these different technologies have emerged as experts have said, look, they're going to be abused. And look, they are being abused. And that perspective was ignored for a long time. Then tech firms decided that, it was important and they would promise to do better, develop technology that's secure by design, enables privacy by design. Despite all that, we have the growth curve for cybercrime kind of like that. And we just have to assume that all new tech is vulnerable and capable of enabling harm. Speaking of philosophers, Hans Jonas is one of my favorite philosophers. He was the first person and this was in the 1970s, to make the case that not killing plants and animals was just as important as not killing people, that respect for all life and the plant on Earth and the planet was a responsibility of humans, and it was a moral responsibility. So, yes, AI can be amazing, but it's not invincible. And this is sort of a layout of why it's not invincible. It runs on chips, which are vulnerable and hackable and not reliable 100%. And the same can be said of code and data and connections and electricity. I'm going to go through some of these, but not in great detail. If you get the slides, there some examples are given. But let's talk about chips. So, you know, if you remember this, it's moving into the past, but I think around 2016, we started to see this work come out of universities where they were finding that you could steal information by attacking the CPU, the Intel or AMD, the core processor in the system, using data leakage and side channel attacks. Some of these were known were Spectre and Meltdown. There was one called Rowhammer, which looked at getting information out of the RAM chips. And yeah, this big deal. And it points to a theme within this whole history of technology abuse, which is the technology is typically pushed out without enough testing and pushed out with compromises. So what we found at the root of these problems with Intel chips, which could be hacked, was that Intel had taken some shortcuts. It had made some trade-offs between speed and essentially hackability. And this has happened over and over again. Home routers or routers, depending on which country you're in, they would come out with new ones which were faster and better, but that was achieved by making compromises in the architecture and so on. And that is going, and unless people change their approach to developing technology, that's going to continue. BIOS chips, the basic input output system, which we now call Unified Extensible Firmware Interface or UFI, that is a chip that's at the heart of every digital device. And if you can get to the code that's in that chip, you can take over a system and it'd be very, very hard to detect, because historically attention has not been paid to that. It was kind of assumed that nobody would be touching that. You would actually have to get to the computer itself to do that. But those chips are being attacked. A friend of mine, Alex Matrosov, who was a brilliant Russian mathematician, but he's now a brilliant American computer engineer, started a company called Binary, and that's what it does. It helps organizations deal with problems in their BIOS chips. And chips can fail, you know. If you've ever developed a gaming machine, a desktop machine to do gaming, and you want the fastest, hottest CPU, the clue's in the hottest, right? You have these big fans on there and cooling systems so that you can run the chip faster and faster, which heats it up, and you have to keep it cool. Back in 1989, I was writing books for a company in California, near San Francisco, when they had the earthquake. I wasn't actually living there at the time, but the publisher's building, had to be evacuated very, very quickly. And people didn't turn off their computers, they just left them on. And at some point, the air conditioning failed, but the computers stayed on. And nobody was allowed back in the building because it was damaged for about a week. They couldn't get in. When they got in, a lot of the computers had died because they'd overheated running in an office without air conditioning. So code, for some of the reasons I've mentioned, can be unreliable. People take shortcuts, and there can be genuine errors that weren't intentional. If you look at the bottom line there was a radiotherapy device for cancer treatment called the Therac 25. And this is back in the 1980s. If you're into programming, you'll know of something called a race condition where there's a conflict and code executes without appropriate limits. And that happened in a way that caused the machine to provide a much higher dose than it was supposed to. The technicians operating it did not realize that it was giving the patient a much higher dose than the instruments indicated. And I think 6 people died in that incident. And so problems with code have been a known problem, certainly, since the 80s. You know, it's not reliable, it can be hacked, and it's vulnerable to hacking. Data can be poisoned, data can be stolen, connections, those can be interrupted, those can be hijacked. They are vulnerable to hacking and are not 100% reliable. And electricity. Um, how many of you, I think I can see if you raise your hands, how many people heard what went on in Spain and Portugal yesterday regarding electricity? All right. Yeah, so I happen to know because my brother and his wife live in Spain, have done for a long time. And it went out, the power went out about 12 noon and didn't come back till 5 o'clock in the morning. And internet didn't come back until 8 o'clock this morning. And it was an outage like no other. I mean, I started working at ESET in 2011, and about 2 weeks into my job in September, I think it was, there was a power outage in all of San Diego. But you could still use your cell phone if you had battery in the phone. You could still make a phone call on a landline because landlines generally uh, don't use electricity at your end. It wasn't the same kind of blackout where the radio stations, the TV stations went off air. There was no way to find out what was going on because even the people who had some idea of what was going on couldn't tell everybody. It was a total blackout. And I think it's going to be kind of a historic event in human relationship with technology because you can just see from that, 12, 18-hour outage, the amount of chaos that was produced. And of course, during that time, not only could you not get money out of banks to pay cash, um, you, you couldn't use your AI to answer any problems or deal with any issues. So it's important we realize that AI is just chips and code running on data connections and electricity. So let's look now at how AI is evolving in a time of growing cyber badness. So ideally, AI would be developed in a way which initially kept it away from abuse. But we have, as we saw from this chart at the beginning, a lot of abuse of technology going on. I use this term cyber badness. This is another example of a term that was coined by a security guru. This was, I'm not calling myself a guru. Cameron Camp is a guru of network security. And he knows more about security on networks than anybody I know except my wife, who happened to write Network Security for Dummies. But it's a great term because it encompasses all of these things that go wrong. Nation state attacks, criminal fraud, deception by post or email of things which were made digitally, just every kind of thing. And it's also, in a criminological sense, useful because one of the issues that criminologists had when cybercrime started to happen was it wasn't a crime. The crime acts in the UK and the US didn't come in right away. And certain crimes were just novel. For example, sharing the customer list from a video rental store and showing what customers at a video rental store had been renting, which was data privacy invasion. That wasn't against the law when it happened the first time, and Congress acted faster than it's probably acted at any other time and passed a law specifically making it illegal to share who had rented which videos. But In the early days, the 1970s, the first books about cybercrime were actually about computer fraud and abuse. But basically, if you're working with any kind of cybersecurity, whether it's defense, whether it's investigations, whether it's deploying AI for security or just for use within an organization, you're going to do better in your risk assessment when you know how devious cyber criminals are and how vulnerable the technology is. We've looked at the vulnerability. So how devious are the criminals? Well, they've been at it for a long time. I won't go through all of these, but this is a timeline by every 5 years, what was hot at the time in cybercrime, all the way from just experimental hacking, phone phreaking, so tricking the phone systems into giving you free calls back at the time when you had to pay for a long distance phone call, insider threats. Now, in 1975, most of the computers in the world were all locked away because they were mainframes and they had restricted access. So 80% of problems back in the 70s, you could say, were insider and 20% were external, maybe. Now we've flipped that around. I'm pretty sure it's about 80% are external in terms of frequency. I still say that an insider attack is the most devastating or can be the most devastating attack. Now, in 2025, we're dealing with supply chain attacks, which I mentioned, AI-powered scams, and misinformation, which AI is quite good at amplifying. So cybersecurity, and I've talked about this really, it developed as a way to deal with things that were bad and spotting them, whether it was bad code or later on bad behavior. And it was found that AI really can help with that. So we're seeing products now that are doing quite well at detecting anomalous behavior by users on a network. And that there's a shift from rule-based to adaptive responses. So AIs can log something that you flag. This is a specialized artificial intelligence system for security. You can tell it things and it will spot those and then it will learn new things and add those. And it can lead to faster detection, quicker decisions about is there an intrusion or is there not, and reduces the amount of time potentially that people can get into a system undetected. But through all of these uses of AI in cybersecurity, whether it's doing a better job at spotting a phishing email or identifying a fake person, human oversight due to AI error is important. AIs can still hallucinate and can help the bad guys. So here are some of the ways we've seen a surge in phishing attacks, which are using AI to improve the effectiveness of the hook they put out there to get you to hand over information, social engineer information out of you. It makes that threat smarter, potentially more dangerous, easier to execute. I mean, we had phishing as a service available on the dark web for the criminally minded to get involved in doing phishing, and you could get that as a service. But now that service has got AI enhancements on it. Malware can be designed, and we've seen that an AI can write malware on demand. You can produce malware even without knowing much programming. And malware can be used to obfuscate. AI can be used to obfuscate malware. Hiding your malicious code in something else is been a long-standing practice. And there's some good papers out there on how that is being techniques for obfuscation, which are compute intensive, are being taken over by AI. There's a good paper I should mention, it's in the notes, called Inside the AI Arms Race, which goes into a lot of detail about some of the ways in which this is happening, because you can actually attack defensive AI. So we've got this arms race between using AI for defense and then messing with the defensive AI. AI is also being trained to use legitimate tools. So we saw 10 years ago, advanced hackers in a penetration using built-in tools like PowerShell and Windows management instrumentation to do their dirty work on the network, because it wasn't a tool they had to import. They didn't have to bring in their own hacking tools. They could use tools already on the system. We used to call it living off the land. And then there are the deep fakes. Okay, so AI generated deep fakes can be very convincing in a number of scenarios, whether it's voice or video, and synthetic identities can be created. And we've seen some actual crimes out there committed by people who just don't exist. They're a complete figment of AI's imagination, as it were. I don't think AIs yet have imagination, but AI can build a fake person very convincingly. And this spreads across all of the media, whether it's a phone call, whether it's Zoom or video, whatever. And we'll look at an example of this. So, as promised, we have Nicolas Cage. Okay, and this is Nicolas Cage on a Zoom call. It's a bit difficult to see the Zoom controls, but I can assure you that's a Zoom call. And that's Nicolas Cage. The question is it really Nicolas Cage, Your Honor? And no, it's not Nicolas Cage. It's a chap called Perry Carpenter, who's been in cybersecurity a long time. He has the grey hair, but he's been around, and the last few years, he's really done some great work explaining deepfakes and the threat that they pose. Okay, so I'll just play this video and see who else is involved.
So here's the final question with any deepfake is, will it tailor or will it swift? So let's check that out as we see how well this adapts to Taylor. There's Nicolas Cage with Taylor's hair. Again, that may also be my new favorite thing. Okay, so let's go back over to the software. We'll grab Taylor's face. And just like that, we get Taylor Swift. And then just like that, Taylor Swift in Zoom with some additional.
Yeah, that's always the tricky part.
Sorry, can't get the hair just right. Pretty darn good.
Yeah, getting the hair right is really
the image quality on that. I mean, that is pretty freaking phenomenal.
So that is part of a longer video, which Perry shared on LinkedIn. One of the points he was making with the video is not only like how easy this is to do now, it is how scary that ease of use is. And you used to be able to do the deepfakes somewhat like that a couple of years ago, not that quality, but it took a lot of different pieces of software and jiggering around with it to get it to work properly. That is produced by a one-off program, a single program. You download it, you run it, and it will do those things for you. So you can get into a Zoom call with an executive. I probably wouldn't pretend to be Taylor Swift, but you could pretend to be someone that the executive knows. And if you plug in a voice synthesizer as well, yeah, you can pretend to be somebody else quite convincingly. And ironically, we're used to Zoom calls having a little bit of artifact, a little bit of blur if somebody, actually this is doing pretty good. We're used to the fact the image isn't absolutely right, but he does some tests in the rest of the video which show this is capable of doing a high frame rate and avoiding tells. So let's think about these things, and as we talk about possible impacts on forensics. I've listed this one of N because the number of different impacts is still being understood, I think, and still emerging as new levels. For example, we have now 2025 will probably be the year of the agentic AI, which is given tasks to do independently. So one of the things we can see is that the tools that are used in forensic triage or evidence sorting, those could be messed with. Those could be tricked into ignoring critical data, for example. Things like log files could be changed by an AI-based program, and AI-based detection systems could misclassify or miss key evidence. Nobody likes going through logs. A lot of companies, a lot of people use some sort of software to analyze the logs, but AI could probably do a lot of that faster, and particularly if you wanted to mess it up and throw in a few errors. Investigators may need to verify then the authenticity of digital media, things like forensic watermarking, or AI-based detection tools mean we're potentially facing another arms race where the investigators are using AI to look at things, and the bad actors, the malefactors, as I like to call them, although not many people do, the bad actors, they're using AI to fool the AI that the investigators are using. Another area of impact is around not just the data, but its context. You know, I read a lot of detective novels, and you'll often hear the detective saying, "Well, the more we know about the victim, the quicker we can solve this crime, or the more we know about what the potential murder victim is like, or if we have a named person, we can move on with the investigation." Well, how about we interfere with that through social media, swamping social media with alternative theories of who it might be? I mean, one of the classic defense of reasonable doubt in a crime is in the jury's mind. And could they be influenced by an AI developed and orchestrated media campaign? The, the reality is that fraud feeds on deception, and artificial intelligence is excellent at deception. You know, if you can create for the potential fraud victim an alternative reality with convincing, and in the past this was done, in analog terms, a convincing business card, a convincing letter, convincing alternative reality, false realities. AI can orchestrate and generate that much more quickly than humans can. And that's, I think, where we're going to see a lot of the problems from malicious use of AI, is using it to deceive people and thereby trick them out of money and information. So winding down now, I promised some good news. So the big bad AI, the artificial superintelligence, as in Skynet and other doomsday, Armageddon, apocalyptic movies, will be just as hackable as any other AI. I see no reason to think that artificial intelligence will ever develop the ability to be invulnerable. And you can think of lots of scenarios, good, science fiction scenarios in which, when things are getting really bad and people, you can see what's coming with the AI, it's about to turn on us, and you hack it to stop it. And yes, I think a artificial superintelligence will be stopped before it goes too far. Um, I'm still concerned about the history of technology. And here's a little piece of history. I don't know if anybody can tell me who the person on the left is smoking a cigar there. That's a photograph from a film set in 1936. And I can guarantee you have read or something written by this chap or seen something, a movie based on his writings. That's H.G. Wells, who wrote Time Machine, War of the Worlds, and so on. And he said back in 1932, all these new things, these new inventions and new powers come crowding along. Every one is fraught with consequences, and yet it is only after something has hit us hard that we set about dealing with it. And that is pretty much the history of cybersecurity so far. Hopefully we can do better in the future. So I thank you very much for your time and attention. I don't know if we have possibility of questions, feel free to email me. That's my address, scob@scob.net.
I have a question. One of them was about the legal admissibility of data that was acted on by AI tools, and particularly a court of law. I know it's the difference between the United States and the UK in terms of like the court system and how that's operated. But do you have any opinion on the use of AI tools in a criminal forensics trial, for instance?
Not really. There's one example. I don't have the details to hand, but a lawyer did present material to a judge, which had come off of AI and was rapidly thrown out. There was a recent example. You can probably find it with Google. Somebody, and this was, I'm pretty sure in the UK, was going to appear in their own defense, and they used a deep fake to do that. So you had an older gentleman using a younger person on a video-based court proceeding, and the judge, I think, very quickly figured out that that wasn't right. Yeah, I think probably what's happening in the legal area is that law firms are using AI, and there are AI tools for case research, for writing briefs, and a lot of work. I'm pretty sure most of it at this point is being, human checked before it gets into the courtroom situation. And to be honest, I can't think of a situation where AI output was used as evidence.
Perspective of like tools in the future that might check for something automatically using like an open source tool or any kind of data that they scratched off the internet saying, hey, this is applicable to the situation, but it's generated by AI, the truth of it can be
Yeah.
Debated.
Yeah, so I think, and as I mentioned earlier, the fact that lawyers seem to be keen on using AI is probably sensitizing the legal system to that, right? To check things, check, presented evidence against reality. Certainly, and I shouldn't sound so down on AI in that I'm using AI in my research. What AI is really good at this point in time, something like ChatGPT, although I'm thinking some of the others might be better, is to do work that you already know how to do. So in an academic area, you need a literature review, right? Do not submit in a paper a literature review that came straight from ChatGPT. You need to write the stuff yourself. But if you need to do a literature review, artificial intelligence is a good place to start. It will hit a lot of the high notes. It's good at summarizing things, and it's good at laying things out. But again, you have to, you shouldn't do that if you don't know how to do that, so to speak. If that makes sense. I mean, you can speed things along, and you can get into interesting conversations in that, if you're trying to narrow down, you're trying to learn about something you don't know, but you do know how to learn, and you do know how to evaluate the responses to questions. Yeah, it can be very helpful, and you can expand your area of knowledge about a subject. And I think in some of the articles I've read about forensics and AI, that's actually been noted in that, a case comes along and it's, let's say it's in the automotive industry, and it's in parts distribution. And, you don't know anything about parts distribution. I've got a friend who used to work for Jaguar Land Rover. He told me a lot about parts distribution, but I know, I'm not an expert in parts distribution. How can I get the lay of the land? Can I get context around something that's new to me? If I'm investigating, if I'm looking at a computer that's part of evidence seized, I come across something I've not seen before, ask AI about it. I have found that Grok is particularly good on technical questions. Um, it goes into considerable detail at answering some things. So, yeah, you can use it to expand your knowledge, and you can apply that expanded knowledge to tackle problems you're faced with in your forensic work. Um, whether we'll get to the point where, there's definitely going to be a point where there'll be a test case about some statement of fact which is generated by an AI, gets challenged as part of a case.
Thank you. Any other questions? Okay. Thank you so much, Stephen.
My pleasure.
Okay.
Do you still have your CISSP certification?
Good question. Yes. So coming up, I might let it lapse when I get to 30 years, which is next year. So yeah, I laughed because apparently ISC2 has sometimes gotten like picky about people saying that they were a former CISSP. Like you're not supposed to say that because you have to be a current CISSP. And I currently am with all my credits up to date. But I honestly, when I left ESET, I didn't retire from work. I retired from that job. I thought I was going to do more work where I would need the CISSP. Then my wife became ill. Haven't done as much work, but it's served me well over time.
Thank you.
Okay, thanks very much, everybody.
Okay.
Thank you, Stephen. Thank you very much.
Thank you.
Okay, cheers. Take care. Have a good rest of your day.